Fantastic. Good, man.
Excellent.
Sorry, Brad, I'm going to get you from here.
Sorry.
So, as you know, we've come out with a couple of new scanner offerings. What I'm showing right now is our Saturn 1, and what I have connected to it is a DSP-based amplifier. So it's all digital. It's basically receiving a command signal from the Delta cable here, digitizing that analog command signal into a digital form, and then calculating all that stuff through a digital servo. The digital servo algorithm is similar to the kind of classic analog servos that we're all used to using. But the difference is that everything is 100% digital, so nothing can drift. And also, everything that's built into analog servos, that circuitry, is actually accessible in the servo algorithm. So all of basically what makes up the resistor values, that makes filters and amplifiers and different circuits like that, we have accessible in the algorithm. So the way it's tuned, I have a built-in function generator here, and that's what's running this thing. We can do a sine wave or a square wave, and we can adjust the frequency up to 500 hertz or down to probably less than 1 hertz. And control the amplitude here. And so what I'm looking at is it has a built-in oscilloscope function too. So that's what I'm looking at here on the computer screen. And all of the actual servo. So if we were to take a look at a schematic diagram of a servo, we would be able to then take a real scope and tap onto different parts of that schematic diagram and see what's happening on that. So when we're troubleshooting or designing a servo, this is what we do. We take the board and we tap on the scope with different test points and that sort of thing. So what I've got here, this little sheet here, is a diagram of what the servo is and all these little test points here which are identified. And so just as you can take a real physical scope probe and tap onto some part of the circuit, I can, in a little drop-down list box here, tap onto anything. So what I'm looking at here, and just like we have in a real scope, we can zoom in. Here's 50 microseconds per division, and I can take a look at my command signal here, my position signal current, and I can have up to 4 scope traces that I can look at any time, both X and Y. And so basically, it's got a built-in function generator so that you can do scanner tuning. It's got a built-in oscilloscope, and it also has a built-in dynamic signal analyzer. I'm not sure if I can show you that here or not. I might be able to show that to you. What that does is it will basically run a sweep function of the servo and the scanner and give you a frequency response plot of that, from which you can then make even more accurate adjustments. So, what we're used to tuning with our classic scanner amps is things like servo gain, which I can grab here. The power supply takes a second to reboot on this. I'm not sure what's happening there. Let me do something. Yeah, so it's set to 30K, and I was just tuning. So here's my servo gain.
Yep.
Here's my damping control and high frequency damping. And what's neat is that our scanners really track really well. So every scanner you get from us is going to be the same. And so what's cool about it is that I can tune X and Y at the same time. So if I'm tuning something up from 0, I can say, okay, well, I'm going to increase servo gain, increase damping, increase servo gain, increase damping. And the neat thing is, I'm doing, it's like I got 2 pots and I'm adjusting both at the same time. If I want to, I can just click on the X-axis and only adjust X here and get X going, and then click over to Y, and then adjust Y separately. But it's just kind of neat that I could adjust both X and Y at the same time. It just kind of makes setting up the scanner a lot faster. So you got kind of your classic things here: servo gain damping, high frequency damping. It's got your typical things of what's the this is like your input gain control, and input offset control. So since I'm moving both at the same time, things like that. What's neat about it is that just like in Beyond, all of these things are controlled with sliders and spinners. So and if I want to get back to a default setting, all I do is right click on it, and it will reset it to its default setting. So so right now, this is not a self-tuning scanner amp, but what I have in here are some things where it's kind of constantly computing the overshoot and the step time and different parameters like that, and the PC can read that through the USB cable. And so what the plan is for the PC to be able to automatically tune the scanner amp. So the amp itself won't tune itself, but it'll be like a PC-assisted tune, which you can then go into and then tweak it yourself if you want to. One of the neat things about it is that, like I say, there's a couple of tools that are built in. The oscilloscope feature, as you already see here, built right in. It's got a built-in function generator. It's got a built-in dynamic signal analyzer, as I was saying. But one of the neat things is that another tool that it has built into it is the modifier. Here, I'll show you that here in a second. I'll switch over to 60K. So I can switch tunings just basically at the click of a mouse. Now, with the firmware that's loaded in here now, it takes a few seconds to switch the tuning, and I've done some firmware. I just didn't load it into this particular board that will switch it a lot more quickly. But so now this is running at 60K, and if I take a look at the error modifier, this table here, this kind of funny shape, is when we input a signal, it has to be modified in order to keep the servo stable, especially when it's running it at a fast rate like that. If I slow it down, like this here, so now it's back down to the 30K tuning. And if I take a look at the modifier, it's linear. And so what's happening here is this. We put in a signal, and then it gets modified before being sent to the scanners. With 30K scanners, normally this modification is a square root function. But with our scanners, they're fast enough that in the 30K settings, it can be completely linear. So the benefit is that we can display a 30K tilde test pattern really, really big. This is about 32 degrees. And so, and the reason why I wanted to, you guys have your projectors back there. The reason why I wanted to put it here is to show just how big this can get. I mean, that's the tilde test pattern. It's just playing at 32 degrees. All the other patterns that I could be showing you can be displayed full size. Here's the tilde test pattern here. And we can go, all the way. That's about 50 or so degrees right there. I'll show you something that I talk about on the forums, but I'll be able to show it to you here really easy. So there's the grid. So you can display the grid, just full size 30K, no problem. All right. So one of the things I talk about on the forums is that the physics involved in scanning with respect to heat and how the current works and how the motor produces torque and everything, that frequency is a square function. And so what it means is that if you double the frequency, you need to cut the size by a factor of 4. So here I could display the ILDA test pattern at 30K at 32 degrees. But when we speed up to 60K, which I'm going to get there now, so go down to 60K here. And I'll speed the scan speed up to 60K. So that's 60K, and that's about 8 degrees right there. That little twitching in there has to do with it's something I discovered just after the Pro Light and Sound, the Photonics West trade show. It's something with the current amplifier, and I just need to change one resistor value, and that will solve that. But I didn't discover that until just after the meeting. But that's 8 degrees right there. So this system, normally to display 60K at 8 degrees, it takes a Cambridge set of 6215s plus their high power amplifiers, plus usually 28 volt rails. And this has got, just plus minus 24 volts in here, and it's just running, this is a dual amplifier, and it's pretty small. So this is just a much easier way to get to 60K.
And which scanners again are these? These are the...
This is the Saturn 1, and so the way our part numbering works is we got Saturn 1, 3, and 5. Saturn 1 is for 1 to 3 millimeters, and so this has our 3 millimeter mirrors on it. This is going to give you the fastest performance because 3 millimeter mirrors are small and light. The rotor inside this scanner is the lightest rotor in the whole industry, and so this is how this is how you make things fast. Making it small and light. But the trick is to make it light enough without sacrificing the stiffness, because eventually, the first Saturn ones that I built were a lot longer. I was just trying to get more torque out of it, but it wasn't stiff enough, and so all of a sudden I started seeing all kinds of bending and just all kinds of artifacts in the imagery. But so it really is a trick to get the kind of the speed while also keeping it stiff and strong. And so now here's the table for 30K. It's just linear, and here's the table for 60K. You can see that it's a lot more nonlinear. So what we've got to do is correct this. And so what's neat about it is, even though we can only display the ILDA test pattern at 60K, we can display any of the other patterns, at much larger. So, like for example here, this laser media test pattern, we can display this pretty much full size, and this is still running at 60K. So, what I could do is actually show you real imagery, and it's a little test. And I'll kind of prepare myself, set myself up here to show you the next step above 60K. So what I'll do here is 2000 shows. What I'll do is I'll show you our revelation graphics, our standard revelation show. I'm going to not show it in Showtime, but through LD2000, just doing a frame animation with it. I'll switch this back to 30K, and I'll show you what it looks like at 30K. And then I'll switch this to 60K, and also speed up the graphics and show you them at 60K. and then we'll actually take a step even beyond that. So, all right. So let me switch this back to 30K. So now I think. All right. So I'll change the scan rate back to 30K then. And the neat thing about these particular frames is they already know what sample rate they're supposed to be running at. So prepare me for the next step. I'll change the scan rates to just allow me to control it instead of it controlling it. So. So we'll make this maybe that size there, and I'll just let it roll. So here's our revelation show at running at 30K. So you'll be able to see what it looks like. You'll be able to see kind of the level of flicker that comes in, what the graphics looks like. That particular part was really flickering pretty badly. Yes. This is the 30K setting running at 30K. We got some ambient light in here, which is good, so that you can kind of perceive the flicker a little bit more. And I'm not sure what kind of palette I've got going on here. So this scene here was flickering pretty good there when it was zoomed in. So I'm just going to go ahead and stop that. I'm not sure what the heck is going on with the size. So what I'll do is just do 60K then. So now it's 60K, but it's still running at 30K. So now I'll speed it up. I think so. I'll speed it up to 60K. I think I need to use a different color shift as well. There. Okay. Yeah, I'm apparently animating through the whole, through the test patterns and everything, and the power supply in this projector is the default, is the one that came with Quant, and so when it went to display all those test patterns so big, it needed a lot of power, which the power supply in here couldn't provide, and so it shut down and shuts off the whole computer when it does that. So okay, here we go. All right. So I'm doubling every frame too, because it's, you know, I'm having to repeat every frame to keep the timing the same. So you remember this part, that part flickered pretty badly in the, when it was running at 30K. So you see it looks basically exactly the same, it's just running at 60K, so there's just a lot less flicker now. And what's interesting is now it doesn't look as smooth because each frame is actually, it's being scanned twice. You know, it feels a little jittery, but the reality is it's just because it's having to repeat every frame. Yes, now there's, you know, it's barely even perceptible, the flicker there. Yeah. So just before coming here, smaller. Just before coming here, I was kind of messing around with this thing a little bit and cooked up a 90K setting. Yeah. Wow. Okay. So let me see. I think I didn't really completely optimize that. That's what why we're seeing a bit of jitter there. But I'll speed the actual scan rate up. So that's 90K, but the test pattern's got to be really pretty small. That's about as big as I can make the test pattern itself to display this here. But the other test patterns can still be shown much bigger.
Hear the Christmas. Hear the rose.
So, all right. So we'll take a look at the laser media test pattern, and so I can display it about maybe a bit bigger than that, really. And this is actually running at 90K though. And as I start making it bigger, it will do this. Now I can kind of bump that up a little bit, cheat a little bit, like this. At the office, I had it running around here.
Ooh.
But what we'll do is actually show some actual material, and I can show that at should be able to show that at about here.
on in.
I'm going to set the color shift as well. Let's see. So now, interestingly enough, if the projector was back there, this would probably be able to cover this whole screen.
Mm-hmm.
Probably have to water cool instead of Cambridge from this one.
I'm not sure. It could be.
It's running faster.
Yes,
It is running
because
faster.
I'm not tripling every frame right now. Yeah, I can actually make it run the same speed like this here. Right? Yes? Look. Yeah, there you go.
No flicker at all.
Well,
No
Okay.
flicker at all.
I've seen planetarium instruments that did project stars there nicely.
Yeah, so I'm not sure what's going on with it. A little bit of distortion there. Something that we're still working on. And I just hit that full-size test pattern.
Power supply went.
Yeah, exactly.
Yes. Yeah.
I get a rest.
Only for 2 seconds. While the poly switch resets.
Get up, Rod.
Get up.
Yeah.
Back to work.
I think that's set back to 30K now.
Oop.
What's happening, I think, is that the amp is actually getting pretty hot. And it's just sitting here. It's not really bolted down or anything.
Can't imagine why. It's not like it's doing any work.
Yeah. Yeah. So that's that's what we got going on with this.
So that amp's going to work for the Saturn 1, Saturn 3, and Saturn 5s?
Yeah, it'll work for any of our scanners, including the Compact 506, which I'll show you next. I brought this projector. I brought these scanners, and I'll show you these things here. I guess I'll just set them here, and you can kind of walk up to it and take a look at them. And we had a client who's a stereolithography client. It's a 3D printing company. And they're currently using Chinese scanners, and I'm not sure if they get them on eBay or what. They're using a whole lot of them. But they met us on at the Photonics West trade show, and they said they saw that we were making these scanners and said that they would like better performance, but didn't want to pay more money. And they were surprised when we said that we can give that to them. And so I said, well, I'll tell you what, send me your current scanners and amps. I'll take a look at them because I want to see what kind of performance you're getting right now. And what they were getting was a pretty poor 24K at 8 degrees.
Oh my
And
God.
it was pretty poor. It was a lot of overshoot. And so I took pictures of what it looked like before. And these amplifiers here, they just have little LM1875 op amps on it. So I didn't really know what they were going to be able to do with these scanners. But this past night, I was kind of working on that, and I'll see if I can show you what it will do.
No, we're just going to swap a whole set of scanners out of a projector.
Yeah,
See the stuff he needed.
in a matter of seconds.
Yeah.
In a matter of seconds, yeah,
I
yeah.
seen him put scanners on, attach scanners to that thing with gaff tape.
Well, that's what we do. In fact, that's why I
Hey, at least he didn't use poster putty like another Pangolin employee.
Hell yeah.
The Ghetto Fabulous Projector. Copyright Aaron.
Hey, if it works, it works.
2007? 2006? Something like that. Circa FLEM version 1.
That was cool.
That was kind of cool, wasn't it? Yeah, yeah.
Now, Bill, just out of curiosity, this company that's using these scanners for their 3D printing or whatever, what kind of performance are they requiring for that purpose as compared to us watching a laser show?
Well, you know what's funny is I asked them how quickly they scanned, and they said that they thought that they were scanning pretty quickly. But I think that with their question or statement, or that their knowledge was basically in a vacuum. They don't know. They don't know what pretty fast is. They don't know what
Yeah, because obviously the difference in definition of fast could be different from industry to industry.
Well, sure.
Well, I mean, let's face it, if they could only get 24K performance
Yeah.
at 8 degrees, yeah, you know. Give them a set of Saturn 1s, they'll shit themselves.
Right. Exactly.
Don't even know the look out.
That's not gonna, that's shocking. Okay.
He's told us the fastest moving glass was the windscreen on the space shuttle. And the optical scanners were in second place. I'm not so sure about that now.
No, something's okay. All right. So, since I did a lot with just red and no blanking, I'll just show this to you guys. So this is the ill-detached pattern. This is 30K right now. So you can see, actually, looks like I'm tuned up a little bit faster than 30K. But this will do 30K at about 12 degrees with these amps, which I thought was really impressive.
Yeah.
So those are the amps that came from the
These
company.
the cheap 24K
Yes.
ones from China that were only doing 8 degrees.
Right, and you see that the pattern really is perfect. And even as I get bigger, it doesn't really freak out or anything. It's just it stays pretty well controlled. And obviously, this is just a little test pattern. As I go to other patterns, like this here, should be able to go basically full size.
Oh,
And
yeah.
this will go really close to 60 degrees.
Wow.
Just an 1875 drive.
Yeah, yeah. So this was really pretty surprising to me, especially the grid. The grid pattern is kind of hard because after a while it will start, the end will start bending. But even this one, I mean, you can get that
Jeez.
Good
really
Lord.
super big and still holding together pretty good. So this is kind of the 30K we're getting with these scanners, and it's really good 30K. And in the haste of coming up here, I didn't bring another one with bigger mirrors. We've got ones with much bigger mirrors that will fit on here. Will fit 5mm square laser beams. So and still do basically what you're seeing right here. It's one of the things that this company wanted to evaluate. They said, we're using these mirrors that come with these scanners, but we can't put bigger ones on, and we think we need a bigger mirror. And so they're going to be evaluating both this and also our bigger ones. But we can deliver basically the same kind of performance you're seeing right here with those bigger mirrors.
Are they interested in your DSP amp, or are they going to be using analog amps?
Well, it's a consumer application. They want cheap, So what I'll do is we'll go right back through. Let's see. Once again, it's 30K. Let's see. I'll move this down and maybe to the right a little bit, and we'll see how this is in terms of size. Okay. Looks like most of that's going to be on the screen. So, Yeah.
That's what you would see.
That's exactly it.
Yeah.
Yeah.
Did you modify those amps at all?
Oh yeah. Yeah. It took me a while. They did not want to do. Most of them, you know, it's like 6 components and it's done. These were not having it. And it was wrestling.
How similar was the servo?
Oh, it's exactly the same.
Yeah.
Everyone's copying the original Cambridge servo, and it was frustrating why it wouldn't just work. You know, why it wouldn't just change the same old 6 components. But I had to just wrestle with it. But yeah, and in fact, let me see. I haven't actually tried this, but I'm sure it will work.
You're not going to push those to 60K.
No, not 60K.
I thought they're the same exact name.
Yeah, I was like, wait a minute.
Close to 60 degrees. I'll push them big. Yeah.
Wow.
So it'll display the, it'll display this whole show.
So if you were to do this
Wow.
with a different scanner, what would break on a scanner if you just did this and did this?
Well, there's nothing really going to break on a scanner per se. The scanners may get hot and then eventually overheat.
I guess that's that. What would fail in that?
Yeah, I mean, you cook the coil, you get it so hot it demagnetizes the magnet. That's
Melt the glue on the rotor and let it get into the bearing.
stuff like that. Yeah. Now these amps are just sitting. It's LM1875. It's only a 20-watt amplifier. Normally, to drive these scanners, would take a 68-watt amplifier. So these chips eventually, and it's just sitting here. You saw it. I just gobbled it up, plopped it here. There's no real airflow there. There's no conduction path. So eventually, these amplifiers may get so hot that it will actually shut down. We'll see. And at the end of the thing, I'll take this tape off here. It seems not necessary anymore. At the end, I'll let you put your hand on top of these scanners and see what you think of that.
Earlier, you had earlier being like Celine, you had mentioned that these might be OEM only. Is that something like this?
Yeah, probably not now. And what we'll do is we'll just tier the pricing accordingly. Like these guys that are buying, you know, these lithography guys want to buy, you know, tens of thousands of scanners, right. and they want them at a bargain basement price, and they'll be able to get them for that.
Right.
But for people buying one off this, one off that, and the main difference is not what goes into it; it's the support. You know, it's that. Hey, what's this pot do? Hey, how do I switch this from right-handed to left-handed? You know, it's
value of
it's gonna be
time.
a bunch of simple questions, but it takes a bunch of time. Time is money, that sort of thing. Now, all these, the lithography guy's going to have, they do all these same questions, and I'm going to answer them once, and he's going to buy 10,000 of them.
Right.
I'm going to have to answer them 10,000 times. So that's the difference. So, you know, he's going to pay for the support once, and that's going to be it. So, you know, so that's kind of the situation there.
So
Yeah, I can't believe it's that wide and that close.
I know.
I mean, you see it. This is really close to 60.
I mean, I can't do it that wide from back there.
wow.
Well, I could with the PTs, but not with my old ones.
That's a DD40.
Huh?
Doesn't have the 70 DD40.
Nah, they'd be so hot they'd burn your finger if you touched them. If they didn't fail. Like the last 2 sets I cooked.
Well, you know about cooking scanners.
Oh, hell yeah. Hey, talk to me about crunchy bearings.
All right.
Yeah. I know exactly where that glue goes. Damn it.
Okay, so Adam, since you know about cooking scanners, why don't you come up here and put your
What, you want me to lose my fingerprints?
finger on that block?
Cook something on the scanners.
Nice knowing.
Shit. When I touch it, it's ice cold.
Room temperature or below.
Yeah.
Oh, that's just nuts.
And it's sitting on a stack of circuit boards taped to the front of the
I mean, there's no thermal conductivity at all. I mean, that thing
Yeah.
should be smoking hot. Yeah, it's not even warm to touch.
ice. When I touched it, it was literally.
Yeah, it's cool.
It feels cold because of the aluminum.
No way. I would have lost my fingerprints if those were DTs going that wide.
I thought you'd know that I.
I thought you wanted to
I
leave
wouldn't
it.
ask you to touch it.
Yeah, okay, sure. You were the one who was laughing your head off when I was electrocuting myself with the Houdini box at the last FLEM, weren't you?
That was me.
See, Mark remembers
That
that.
sounds like something Frank would do.
Yeah.
Yeah.
I probably was.
Well, the switch was off. I just didn't realize the terminal contacts were hot underneath it. Yeah. Twice.
Yeah, so this is the kind of performance we're getting from cheap amps.
Right.
And now this whole thing has been really a to some extent a learning process. When we were asked, first we were asked by a company, can you make me a cheap scanner? I said no. we make great stuff, not cheap stuff. And he said, well, I'm going to buy 1.2 million of them over the next 6 years, 200,000 a year. And I said, well, let me look into that. It's only got to go 12K. So I figured, okay, well, I can take our actuator design and I can make it 12K, and it's not a problem. That was his performance target. It's only got to do 12K. So I took our actuator, changed the coils on it, put a position sensor on it, was able to find a way to make our position sensor much cheaper, and put it together, tuned it up to 12K, got there, and said, okay, it'll get 12K, we're there. And I said, well, just out of curiosity, let me keep on tuning this thing. And I kept tuning it, got all the way up to 30K, and I said, wow, that's really pretty impressive. That's amazing. And now let me compare what we can do with this in terms of the angle, in terms of this, in terms of large signal performance, to what Cambridge is getting. And it was the same. And so that's when I knew we had something. Now this happened over a period of a couple of weeks. And so when I first, when I first saw the success on this, that's when I went up to Photonics and kind of started talking about, hey, we're going to have a cheap scanner. And at that point in time, I thought that, okay, it's only going to be an OEM thing. We don't want to make drivers for these things and so forth. But as the performance looks good, and people started sending me then amps for a couple of people, and kind of as a friend or as a favor to friends, people sent me amps. I modified the amp
To work with the scanner.
Right.
with the scanners, and continuously seeing the performance we're getting, and continuously comparing this to the other things. That's when I kind of figured we're going to have to make our own cheap little amp for this thing. And there was enough interest out there too. I had no idea how much interest there would be in these scanners. I figured everyone at Photon Lexicon is just already happy doing whatever it is they're already doing. But there's enough interest that's when we made this other decision. So these decisions have been kind of shifting based on the performance I'm getting, based on the interest shown at Photon Lexicon, and also these trade shows and stuff like that. So that's why basically, to answer your question, my decision has been shifting based on what we've been seeing.
I mean, I think I don't know about everybody, but I'm willing to pay a little more for not a DT40.
Amen.
Right.
Because I don't use Chinese scanners anymore. I gave up.
Mm-hmm.
I gave up because they all melted down at some point. And so usually in the middle of a show, and it's a problem, So
If you book one projector, you better bring two.
yeah, I mean,
That's
and
how
I would
the
actually
middle of
have
the show is.
a spare DT40 because they just melt.
Why were you melting it? I mean, how were you?
Yeah, what kind of?
Put them in a club environment where in the
nightclubs
rafters
are
it's
hot,
115 degrees. And
Yeah, nightclubs are hot.
I blame the pyrotechnics.
Yeah.
yeah.
No, you know what it is? Global warming.
Warming.
No. Global climate change. Now it's global climate change.
I keep saying global warming.
It's more fun.
Yeah. So, yeah, so that's what we got going on with scanners. I mean, we basically got a lot more. We got, bigger ones, different size mirrors and that sort of thing. But
Long term, are you planning to sell these with amps, or are you just going to sell the scanners and have somebody else do the?
oh no, when these things happen, when I saw the interest and stuff like that, I said, well, okay, we got to put together a cheap amp to go with these cheap scanners. Let's make it small, dual axis. So I established a form factor of credit card. We do a lot of things the size of a credit card. So okay, let's see if we can fit a dual axis amp on a credit card. Now, has anyone here heard of ELANS?
No.
Yeah, okay. So this is pretty useful information. I hadn't heard of it, but I'm a member of a business group, and we just talk a lot about these things. And different people find out different things, and then they share the information. ELANS is a place where freelancers go to offer their service to people, and a place where people who need freelancers go to find these people. All right. So, like for example, if you need a circuit board laid out or something like that, you can go up to ELANS and you can say, I'm looking for somebody to lay out this thing. And kind of like eBay in so much that people bid on the job, and they can bid, okay, I think it'll take this much time, and I'm bidding on the job, so I will do the job for you for $2,000. Sometimes they say, okay, I will do it for you for, and it's people all around the world who do this. People in India, Pakistan, literally all over the world. A lot of them in the United States as well. And people will bid, and you can see their star rating. You can read about jobs that they did in the past if it was been made public. And based on their experience and what it is that they're saying, you before you quote unquote hire them, you can communicate with them, ask them questions, stuff like that. So we found a guy on ELANS who knew a particular PC board layout program we use, which is called Altium. It's the most expensive, it's just the biggest, best, most fancy PC board layout schematic capture 3D program out there. And so that's what we use. Neither me nor Ante had the time to actually lay this thing out, and so I created the schematic for this little circuit board on hand-drawn drawings on paper, scanned it in and sent it to them, said, here, you can do schematic capture to do the board layout. So that's done now. And so the board is done, and we will be going to manufacture basically this month. Now, it's a digital lamp. With the success we saw with this, and it's funny just the way, there's the way you're supposed to do products in business. You're supposed to come up with something kind of crappy and start selling it, and then come out the version that's a little bit less crappy, and then sell everyone the upgrade and a little bit less crappy and sell it. We never do it like that. We always say, well, okay, as we're developing, we come up with another idea. We could put some user inputs here, and we can add this other thing here. So now this little credit card driver turned from a cheap thing, probably like these things, basically making this thing here into a credit card. That's where the idea started. To where it is now, we'll use the same DSP software, the same tuning thing. So when we have this thing, when we make the PC do the auto tuning, it will do the auto tuning on this new one too. It's the same communication protocol. It's the same algorithms in there. We got actually a little shutter driver on there too, so that if you want to control a shutter, you can control one of our little VRAD actuators, and it's a PWM, so that it will take the 24-volt supply and switch it down to 5 volts to drive our little actuator, and it's just kind of, the idea is just keep on going and going and going, and so this little credit card, which is going to be a really cheap amp, we're going to be able to offer this whole package, quantity one, at the price people are paying for DT40s. So, and it's got a lot more features. It's a digital amp, and I know, based on what we're seeing here, that we're going to be able to get more than 30K out of these scanners, with this digital amp, because the real pisser with trying to get higher and higher performance out of scanners is these two little diodes on there that create the shape that I was showing you. But the shape really can't be made with diodes, the optimal shape. It changes depending on the tuning you have. I didn't show you the 90K shape, but it's really wacky and radical. But when you do it digitally, we can make any shape we want. So that's the thing. So I know we're going to be able to get better performance out of this thing, multiple scanner tunings, the possibility of auto tuning, built-in shutter driver, and just kind of goes on and on and on. You know, I know we're going to be able to do that and do it at a price that people are paying for Chinese scanners now, but for something that's really solid. And as you saw, we display a whole show full size, and you can't even feel that it's just above ambient. You know.
So Saline 2014, you're going to bring a truckload of these, right?
Well, it makes sense that we would.
Yeah.
We'll see if we can hit that.
I think we need to devote a room at Saline to the Pangolin buy and sell scanner area. Maybe the women's dressing room, instead of being the buy sell trade area, that'll be the Pangolin shop. Just walk in
bring
and
a
buy
bunch of
yourself
safety scan lenses. And, perhaps safety scan lenses.
Huh?
Yeah.
Don't let Justin hear that.
Yeah.
And we got the space.
It'll be a Prius full.
You might just have to buy a bigger vehicle.
You should have brought the Prius B, man.
That's it. See?
The V. What's the V? Van?
No, the bigger one. You have the C, right? The little one?
Cheap. Prius cheap.
Yeah.
The Prius Light.
Yeah.
So, Bill, given that these scanners are awesome and will do, with the amp, they'll basically, no problem, play a show that was made for 30K at 60, does Beyond have any kind of provision, or do you have plans to add a provision for frame interpolation?
What do you mean when you say that?
So, instead of having to double frames, it'll tween for you.
Yeah, it could do that now, but I'm not sure that the results will be perfect.
Got it.
Yeah, I mean, Beyond LD2000 will as well.
Mm-hmm.
You could say you do what we call a keyframe morph over this many frames over this time, and it will automatically go between them as it needs to.
But how about live? Say it's like, okay, someone just gave me a USB stick with a 30K show. I want to play it back at 60 without having to pre-process.
All right, now here's the situation. For most shows, it's no problem at all.
Mm-hmm.
Like for example, if I was to show you a world in motion, which is a point-oriented and vector-oriented thing, the difference between that and our Revelation shows was pre-rendered. And it was pre-rendered with the understanding that it was to be played back at 30K. And so that's why when we played back at 60K, we basically got to double each frame if we want to maintain the timing. If the show hadn't been created that way, then it's just no problem. You just speed it up and go, and everything will work. You know, if you're just taking frames and manipulating them and doing different that, but the computer's only doing that, the computer will understand it. It has a lot less time to do that and automatically fill in between. So,
but if somebody hands you a show that's 30,000 ILDA frames one after the other and it plays for 3 minutes,
yeah,
you're going to have the same problem as you do with the Revelation show.
That's just the frames.
Right, exactly. Because it's not doing any interpolation because it's just playing one frame, next frame, next
It's like
frame.
playing an 8-ash show.
Like playing an 8-ash show.
That's what it is.
Yep.
Yeah. Now the interesting thing is this, and when we, okay, so first the standard was 12K, and then it was 24K, and then it was 30K, and then there was an announcement in 1998 that Cambridge had come up with some scanners that went 60K. They really didn't, but there was an announcement that they did. And that's when the relationship between Pangolin and Cambridge was kind of a bit rocky. And so I took my 6800s and my projector and tweaked them up so that they can go 50K and sent it off to Canada where there's this laser effects conference happening, and where Cambridge brought their scanners. Their scanners didn't go 60K, they went 50K, and they didn't look good, very good at 50K at that time. This is 1998. My scanners did go 50K, and they looked good at 50K. Now, to demonstrate this, what Patrick did was he took 2 of our laser shows and combined them on the timeline and played 2 laser shows at the same time. I think he played Tuesday's Day Off and maybe Creation or something like that. Both at the same time on the same timeline, just to show, look, this scanner is really like having 2 hands. And so that's really more of a possibility. Rather than double frames, you could do that. But
add more stuff in the field.
Exactly. Mm-hmm. Yeah. So that's really,
make a more complex frame.
Yeah. So I think that's another possibility, or perhaps a better possibility.
Especially with Beyond, because now you have unlimited tracks.
Yeah.
keep adding stuff till you end up with hash.
Too bad you can't buy unlimited time.
Yeah.
You buy unlimited minutes on your phone. But
How about unlimited point speed? When's that going to happen from Pangolin?
It's the DLP projector.
Already
done.
yeah.
Which actually, we need to get video of that too, because we did that last night. That MU laser,
Yeah.
it will fool you. It really will.
Mm-hmm.
For audience scanning, it'll fool you.
Yep.
You will. You swear it's real.
Not projecting the wires. It's cool with the 1 watt. That 3 watt, that's kind of free.
We can dial it back. We'll dial it back. But I mean, yeah, it's a stupid expensive projector too. But
That wasn't that bad. I mean, I think I paid $1,900 for it.
I thought you said it was.
I thought Aaron said it was 2,500. I thought.
I think the retail price is $2,500, and I was able to get it brand new on eBay for $1,900.
And that's an LCD, right? Not a DLP.
It's a 3 LCD projector, which is really why I wanted it. It's a home theater class projector. It's 2,500 lumen. So it's made. The most important thing is not how bright it is how black it is.
Right.
Otherwise, you have this oncoming headlines type effect. And so that's really why I got it. In fact, I bought 2. I bought both of them from vendors that said that they offered a return type deal. You can return them. So I bought 2. I took them both to LSDI. We did testing. It was this and a Panasonic. The Panasonic was pretty good. It's really kind of, these things were neck and neck. But the iris, the auto iris on this worked better than the Panasonic. So and it's funny too, because when I took the Panasonic out of the box, because there's all kinds of packing material and how things go, so I took pictures of each phase so that I could put it exactly back together, exactly how I had it, so that there wouldn't be any problem with the return, and it wasn't. And so I bought 2 projectors, returned the one I didn't like, and this is the result. So now DLP. On some level should have a higher contrast. This is, the probably contrast ratio of everyone rates it different. This is supposed to have like 300,000 to 1 or something like that. But it's like you pull the plug out of the projector.
1,000,000 to 1.
It's
You turn it off.
Laser World contrast ratio.
Yeah. Well, I don't know. I think it's like with the iris closed and no input on it, as opposed to a full field of light or something. Whatever. But it's obviously it's pretty black.
Yeah.
But now DLP, in some respects, should be able to do better. The problem is, if you get a single DLP projector, you get that rainbow effect.
Yeah.
And I just didn't really want that. And even I couldn't find DLP projectors that had the same stated contrast ratio as this. This is really. For home theater, the next step up above this is LCOS, it's liquid crystalline silicon. Yeah, so and they get a lot more expensive than this. So this was I really felt was a good a good deal. And it's funny how I ran into this. I was out at a conference, and at night I didn't have anything to do, and so this was in California. They've got a lot of boutique theaters out there. So I found flipping on my phone, went up to Fandango, found a movie. It was called Computer Dating. It was made modern, but it was about computer chess. It was set in the 1880s when they were having these computers fight it out with other computers and play chess with each other. And so that was the movie. So it was in a boutique theater. I went there. They had this projector projecting onto a screen, and so I said, and I was. And it was funny because I was the only one in the theater. So I could actually go up to the screen and see how good the blacks were.
The projector's like, what the hell are you doing?
Yeah, when I was convinced that it was
Now
good.
you know why he was by himself.
Yeah, they call that measure baiting.
Measure baiting.
That's like a real home theater term.
Huh.
Oh my God.
Measure baiting. Yeah, people are like, contrast ratio and signal.
Sound like you got some experience there, Frank. You want to get some off your chest?
I'm an audio fool.
Actually, what was interesting is the Casio projector wasn't that bad.
Yeah.
When we tested it also.
Yeah, we played around with that one.
And they're what, about 6 6, 700 now? Yeah.
It's not as bright though. Yeah.
Yeah, that's the other thing with this. They got to be super bright.
I mean, yeah, that last
Just
night,
to compete.
it honestly, it's about the same as a 500 milliwatt projector, I would
Yeah.
say. Maybe even a little less. But, I mean, to be able to legally crowd scan with no variance,
Right.
you know, what's that worth?
Mm-hmm.
So that being
Apparently,
said,
it's
like,
worth.
Yeah, $1,700. Yeah.
I mean, so how cool is it if Microvision starts making more of their laser video engines? Are definitely well within like an MPE range. You have awesome contrast ratio, and then you're just playing the emulator content through it.
It'll be kind of cool. You got a bunch of
Yeah.
those little things you put the
Yeah,
everywhere.
and I mean it's
Yeah, roll
still a
15
laser
of them, no
show.
problem.
It's just like you're doing rasters.
It's
off
just
the
incoherent, yeah.
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 CDRH has no jurisdiction.
No, occasionally you show an icon of a laser pointer. You're showing you the laser. It's a laser show.
There you go. I mean, honestly, even last night I was surprised. As a trained eye, it was hard to tell. It really was. The spot size on the screen at that distance was comparable to the projector,
Mhm.
to the laser projector. I mean, you could tell. I mean, when you really look close, you could see the color saturation wasn't there. That really was the giveaway. But other than that,
Right.
you're hard pressed to tell the difference.
Yeah, and that was one of the things when we were looking at like saturated reds, greens, and blues. Since it's all done with color filters, the Panasonic had different reds, greens, and blues. But from an overall standpoint, this one just looked better. Yeah, when this goes like green or yellow, with us green or yellow fans, it's difficult to tell the difference between that and laser. Yeah, with saturated reds and perhaps blues.
Yeah.
Not quite the same.
And the white was a little off, but still.
So on a crowded dance floor, and they
Oh, I'm not. I'm telling you. You know,
Right.
Your average raver is never going to know the difference. Yeah.
So I'll actually, just so you don't have to sit them up there, you can.
So, how big is the mirror again on the Saturn one?
It's this size here. It's for 3mm beam at 60 degree in all direction.
And the Saturn 5 is for a 5mm beam.
Yeah, it really goes up to 8mm.
Okay.
Yeah, so it's the one is 1 to 3. The Saturn 3 is 3 to 6, and the Saturn 5 is 3 to 8.
All at 60 degrees.
Yeah.
And what's your expected scan speed on the 3 and the 5?
The Saturn 5 should be able to do 60K with that.
Really?
Yeah.
God, they're tank.
Yeah, and it's actually the XY mouse
I think
is
it's
smaller
fair
now.
to say they'll sell as many of these as
We-
they have quick ship
We
packages.
shaved a little bit off that.
That's 15,000.
Yeah, but how many people have more than one projector that would buy
True.
these?
True.
You know, in the grand scheme of things.
Yeah.
Start building
Yeah.
like
I can appreciate not wanting to service that many people and their questions. You know,
Um,
but
Yeah.
again, you bump the price.
Yes, in
It's
fact.
going to be the same price as
The
buying quick
beam
shop.
entrance height is
Yeah.
the same. The yeah. There's a
Well, you just sold this.
okay.
I've been looking at 62 cams for a while. They're just stupid expensive, even used.
Yeah. Yeah.
Ding, ding, ding.
Yeah.
Yeah.
Yeah. The beam
Sucker!
entrance is 6210. There's a lot that's. In fact, you know, I thought we created a smaller scanner than it turns out we had. Because we did this, we got the mount, we got it in, we put it there. I said, wow, that's really small. And I happened to have a set of 6210 sitting on another desk. I put it up the side, almost the same volume of space. And that was kind of disappointing. It's like, I thought this was going to be smaller. So we had to shave some extra space on. So now it's, and this is kind of the prototype version, the XY mount, and the newer ones even a little smaller. We were able to shave some
Nice.
shave some meat off.
Is that gonna?
Can you picture the size of the projectors, like the 1 watt green diodes, the 1 watt blue diodes, and a couple.
Yeah, and this, yeah.
There's something else too that I hadn't mentioned up till now because I keep forgetting it. But for low-cost applications, for applications that don't step on the gas, and more and more, I'm thinking even for applications that do. These scanners, because it's based on our actuator, have 2 little holes in the front where they can be mounted from the front. We have conceived of a sheet metal mount where you could just screw this thing into the sheet metal mount, and there's your XY mount. And so the benefit is several-fold. One is that it makes the whole thing lighter, because one of the things that this could be for is handheld applications. There are these medical things that they're used for women's, the CO2 lasers, and they just kind of raster the beam so it doesn't burn a hole through their face.
What's wrong with that?
And so the doctors hold this thing. There's a big fiber that feeds the CO2 laser to it, but the scanners are in the head.
Yep.
And so the scanners got to be light. Now our scanners are lighter than anyone else's because it's mostly aluminum. And so, but when you put it with a sheet metal mount, it makes it even that much more lighter. And another benefit is the cost. We're trying to shave every dollar off this thing so that we can pass that savings on to you. And these mounts cost us about $11 to have made, which isn't a lot of money, but still, it's $11.
Adds up.
If we could stamp something out of sheet metal for $1 or less, then
Sure.
it's just that much less money there.
Drones and laser projectors.
Oh, jeez.
Yeah, exactly.
Dude, that's an awesome.
Yeah. I can tell who's going to get us in trouble.
I need the logo
So wait.
way up there.
yeah. You're going to get a call. Why is the Pangolin logo being projected on airliners as they land in Orlando?
Yeah.
Local Tavares man locked up this evening.
I know that you said that you didn't think that the demand necessarily was there, and I can fully appreciate not wanting to necessarily have the service cost associated with selling these as one-offs and everything else like you're thinking about doing. But like I said to Adam, I think you easily will sell as many sets of scanners as you have FP3s. Because first of all, number of people have more than one projector. Plus, the projector manufacturers that are already looking at integrating this. Like you said, Quant's putting this into their projectors now.
Yes. We shipped a bunch to Quant just basically, what was it?
Yeah.
And the last week, the days are all running into each other.
And I would suspect a lot of these other laser manufacturers are all going to do the same thing.
Oh yeah, Quant is using these. HB and switched to these because it's not a Chinese. Like you say, it's not a Chinese scanner.
Right.
The case of HB, and I think Quant too, the way it works out, they're paying the same amount.
Mm-hmm.
They're getting a product that works better,
right.
and it's not made in China. So, there's a little bit of patriotism there,
mm-hmm.
And so forth. And these things. Another thing that what's going to break? Somebody said what's going to break? With regular scanners, the rotor will stop. It bumps up against something, and if you continue to rotate it, you could at least bend something. My first set of 6800, I bent the position sensor vane on them completely accidentally. With this, the rotor spins around and around. There is nothing to break. It will not break.
Right.
Now, what's funny is that these photolithography guys, they sent me a pair of these scanners, and the very first thing I did is I couldn't use their XY mount. In fact, they didn't even send me an XY mount. They get the scanners, and they already machined their XY mount. So I put them into one of our XY mounts, and I accidentally put it in a little too far, snapped the mirror right off because it's so thin. They're 1 millimeter thick, and it's fused silica, so it's really pretty tough stuff. And also, we support the back of the mirror with our shafts. Probably something you didn't really notice, but the way we hold the mirror, it's not just a simple mirror in a slot. There's a big extension on the back where the shaft is actually supporting the mirror. at Pangolin, it's happened to me all the time, and I'm sure it's happened to many of you, and I know it's happened to Adam, that you drop a scanner, it falls on the floor, and it's going to fall towards the mirror and break off. So we were
screw in there, and it hits the.
Well, actually, the one you're talking about was at Salim, and somebody threw a cordless drill into my plastic kit and snapped the mirror off. You had to fix those scanners.
Oh, sure.
Yeah.
Yeah. But Scott and I were doing something. We had a scanner, and it fell onto the floor, and I said, oh, I know what's going to happen. This is really broken. And so we picked it up, and I said, oh, damn, it's not broken. I was astonished, and Scott just said, stronger. They're stronger, cooler, faster.
There you go.
So it's going to be pretty hard to break something on this. The coil resistance is lower than any of the other scanners. So that's why it's running.
That's why it's cool. Yeah. I squared R.
Right. Exactly. So so it's neat. So it's been it's been a journey of not only learning how to make something inexpensively, which we're still continuing to explore. What can we, how else can we reduce the cost of this? But it's been a journey in terms of, what's the demand really going to be like. I knew the first guy what he wanted to do with it, but I had no idea that it would be stereolithography and a lot of you guys and that sort of thing. Cool. Yep. Yeah. So these are, at first I built 20 prototypes, and I took them to Germany. This was just before ProLight Sound. I took them to Germany and showed people. We showed it. It looked pretty good. A couple people kind of took a couple pairs back with them. I sent a pair to Adam.
Norton.
Yeah, Norty.
And I sent
Norty on the
pair
right.
to Stephen Roberts and a couple other people here and there, and then quickly ran out because the more pairs I sent, the more people wanted them. And then so we just got a big batch of parts in, and with which we filled the order for basically for Quant and HB for ProLight Sound, and then now we got another big batch of parts coming in. So I'm going to be able to fill. There's been a couple other photonics kind of guys. One of them is the doctor. He doesn't have any scanners at all, and
right.
And somebody sent me some of these cheap amps here, and I didn't know how well they were going to work. Now I do. It's going to work out real well. So so that's kind of how it's coming along. Yeah.
So they will definitely be for sale by the summer.
Oh yeah, this that amp right there. We've got a little bit more tweaking to do in terms of some components, and but then after that we're going to be we've already got boards that were made. Once the design was verified and any kind of component change were identified, then it's going to go into production. So that's going to be going into production this month as well. Yeah. Cool.
Woo!
Yeah, no doubt.
Yeah, right.
I'm telling you, man. Salim 2014. Pangolin scanners everywhere.
Yeah. Try to get some of those Saturn Vs. Get all that red out there.
Huh?
Try to get all that red out there, on the Saturn Vs. My big.
Yeah.
Mm-hmm.
We'll get John Murphy to build us an Octomom red with the 638s. Yeah. He's actually got a hex design that's making, I think he said 5.3 watts out the front end, and he's got a quad design that makes north of 3.5. Tech cooled.
Oh, there goes all my money.
Yeah. Well, I don't know that he's got the time to build them. That's the problem. There's a lot of machining and so. But yeah, I mean it's doable. It's doable. And the 9mm blues, there's your blue. Put a 1.5 DPSS green and a 1 watt direct injection green.
I just want more red.
Yeah.
I want like half my power to be red.
It is.
Yeah.
It already is.
Yeah, you just can't see it all.
Yeah. A happier red.
Sure.